So, hello everybody, and welcome back to another episode in the Explorica Motorsport and Engineering series. For those of you who don't know, we are SkillShark EduTech. SkillShark EduTech is an academically motivated startup focusing on imparting 21st century skills in the youth of today. Now, what makes us unique is our approach and motive to imparting these skills, and we've done this through a large series of webinars and technical discussions that we've had with multiple tech teams from different universities, and also a lot of drivers and people who are involved in the core motorsport industry. And the whole the point of this entire series is to inspire you viewers to get involved in these sort of teams, to get involved, get inspired to actually apply your engineering knowledge, whatever you learn in your universities. So right now, India, of course, is currently facing a major skill gap, and this issue has been aggravated over the past 1 year because of COVID-19. So, all sectors in engineering domain really need to continually evolve with respect to what has happened over the past 1 year. Now, up till now, we've had, different teams. We've had a Hyperloop team, we've had electric bike teams, we've had a bike team, a motor student team. There's been, a solar team. We've got a super mileage team, and then multiple other drivers that have come from the motorsport industry. So today we have a Formula student team with us. So I'm really happy to welcome DJS Racing on board today. So DJS Racing is the official Formula student combustion team of DJS College of Engineering in Mumbai. Now, they are combustion right now, but there is something really interesting for us to talk about later on in this webinar. Now, DJS has also finished phenomenally well in the recent Formula Parle 2021 virtual event. So they came fourth in business plan, second in design, and they got a second place overall. So big congratulations to you guys for bagging that second place in the podium. So without further ado, let's start off with today's webinar. Can we have a small introduction of all the team members on board on the panel today?
Hi guys, my name is Abhishek Deshpande and I'm the team captain of DJS Racing.
Hi guys, I'm Karan Vora. I'm the team manager. I'm mainly in charge of the operations, logistics, and the statics lead.
Hello everyone, I'm Ishan Maurya and I'm the vehicle dynamics lead for this season.
Awesome. So we have a wide range of individuals from the team, from management and technical side. So I'm hoping we'll have a really robust and wholesome discussion today about your team and your vehicle. So before we get into any of those details, let's go all the way back to the beginning. Where did your team start? Tell us about the story that inspired all of you to get involved in Formula Student.
So actually the inception of our team took place in 2013 when our college newly started the mechanical engineering department, and a group of students came up with the idea to start a Formula student team. In 2014, they built their first prototype, which along with which they participated in Formula Student Germany in 2014. After that, our next event was in 2016, which was Formula Student India. So between 2014 and 2016 was when we designed our second combustion vehicle. After that, we've been designing a combustion vehicle every year. And in 2019, we participated in Formula Bharat in both the categories, that is combustion as well as electric, and we had our first electric vehicle. After that, we've been working on improving our EV vehicle, and from 2020 onwards, we've been focused mainly on the electric vehicle itself. So our team was founded in our first event was in 2014, and since 2016 we've been able to reach close to the podium and getting podium places.
I see. So basically, roughly over the past 7 to 8 years, you've really picked up the pace and done really well. We've seen, this is a really rapid development and improvement for in the broad spectrum of FS teams that we've seen in the competition over the past few years. Something that's really interesting to hear is that you started the team in 2013 and you already managed to go for your first international event the immediate next year, managing to take your first title contender to Formula Student Germany. Of course, FSG being one of the most prestigious FS events in the world, I'm quite sure you would have learned a lot from that, right? How did that experience help in shaping your team structure and the respective subsystems that currently exist in your team?
Talking about the Formula Student Germany in 2014, it gave us a better idea of what Formula Student is about and what the community is about, and that gave us the opportunity to design a second vehicle which was able to participate in FSI 2016 and win awards. So I think it really gave us a better idea of what Formula Student and what Formula Student cars are all about.
And in terms of the structure, what I feel is we realize that making a Formula Student car is mainly it's a project which has a lot of individual projects working within itself. So the way we designed or came up with our structure was mainly in terms of how exactly do we get the flow of information and data between these departments. So we actually have a operations department which includes me and Karan and some other members who are actually managing the technical departments itself. So from a technical perspective, I can say there are a lot of subsystems. Karan, I think you can go to the structure slide. Yeah, the next slide after that, please. Yeah, before that, yeah. So as I was saying, so operations for us mainly deals with the correlation and the cohesiveness that exists in the team between the powertrain and vehicle dynamic departments. The subsystems are mentioned below, and you can see that we have divided our team in this particular way. If I were to talk about each subsystem, particularly starting from vehicle dynamics, the technical subsystem, aerodynamics basically deals with finding the right balance between cornering ability and minimizing drag to get the best form of aero efficiency that we always aim for. So that's one aim that the aerodynamic department always tries to achieve. In terms of chassis, I could say it's the most critical department in our team because it's basically the department which deals with transmitting loads, all the loads that are coming from each department, it goes to the chassis. So chassis is quite critical in terms of that. In terms of other vehicle dynamic departments like brake and suspension steering, for brakes, I can say there is a common misconception that teams are usually going towards increasing the acceleration or going for a higher a longitudinal acceleration. But for a lap time, what really matters is also a deceleration. So brakes is quite important in terms of that. And in terms of suspension steering, what I can say is your geometric and kinematic linkages that exist in the team based on whatever goals that you've set for the season. So that department basically deals with manipulating these loads along with the chassis. So that's how we work with our vehicle dynamics part of our team. And coming to our powertrain, which is fairly new to us, being a new team to the electric category, as Karan said earlier. So we mainly have three departments in this: the high voltage, low voltage, and drivetrain. So the high voltage department is actually used to provide electrical power designed as a function of what the motor requires and in any given situation. And for the Formula Student competition itself, low voltage systems are actually a safety system, and they help in enhancing the reliability of electronic systems in a car. And finally, coming to the drivetrain system, what I can say is it's the linkage between powertrain and vehicle dynamics that exists in terms of load parts. So in terms of team structure, this is how we came about from our past mistakes and whatever feedback we got from our judges. This is the current team structure that we've come up with.
Excellent. Thanks so much. That's a really robust overview of the different subsystems and the team structure that you follow to ensure that you consistently give out top-notch vehicles every single year at the competition. Of course, yes, Formula Student is a constant learning process, so it's good to hear that you have managed to take what the judges have guided you towards in these events. Of course, yeah, like for our viewers, every single team we have on board, it's always the same constant message. It is effectively you working as a company. It's a company simulation in terms of you developing a vehicle from the beginning all the way till the end when you cross the checkered flag, with all the management and business operations included. So it's great to see that. It's good to see your a really compact structure that you mentioned over here. So before we get into the vehicle itself, would you mind telling our viewers what exactly happens in the competition in a quick, 2-minute discussion? Just let us know exactly what happens when you go to a competition. What are all the different dynamic events you take part in?
So talking about the Formula Student event, it is mainly divided into two parts. One is the static events and one is dynamic events. Talking about the dynamic events, there's a skid pad, which is basically an 8 that the car has to make. Then there is the acceleration event. There is autocross where they have a lap and you're supposed to take just one lap. And you get to there are two drivers and each driver gets 2 laps of it. And then there's endurance. Endurance is approximately a 24-kilometer. Is on the last day of the event, and that is what actually tests your car. Is your car able to endure that entire distance? Talking about the static events, I believe the static events are focused more towards enhancing the ability of the team members, because you have the design event where the team is explaining or presenting their design to the judges. After that, you have the cost event, which is extremely relevant in the industry. Okay, anything we learn or you implement into the cost and manufacturing event is completely it's based on the industry, and it really helps students gain an idea of what actually how the industry works. And then we have the business plan, which again gives team members the opportunity to understand even the business side of the idea that they come up with. And in general, talking about Formula Student, it's said that Formula Student is not about getting faster; it's about getting smarter. So it's not the fastest car that wins; it's actually the best design car, I would say, that actually wins.
Yep, great to hear. Yeah, it's not the fastest car. It's the most dynamic car in terms of overall performance. Many people think that racing, first of all, for the viewers, FS is not racing. It's built around a racing concept, but it's got nothing to do with wheel-to-wheel racing. But what people think is a high-performance vehicle is the one that goes the fastest. But we're trying to clear that common misconception. It's not the vehicle that goes the fastest. It's the vehicle that finishes your lap in the shortest amount of time. That doesn't necessarily mean you always hit the highest speed. But surely to prepare yourself for this event, you need to go through a complex design process, right? So could you perhaps run us through, give us a quick overview of what are all the different major milestones that you need to hit during your design process?
Yeah, sure. Karan, you can go to the design flowchart. So we basically divide our entire season into 5 halves, I could say mainly. So we start with the concept phase. So what we exactly do in the concept phase is based on the research and development that has come through the last season and whatever feedback we have gained through our judges. Our design judges usually provide us with written feedback, and also whatever mistakes we made during our process, like during testing, we realized that in terms of accessibility, things could have been a bit more better. So we usually we have a list of these considerations that have to be implemented into the new vehicle which we're trying to design. So the most important and the most critical part of the concept phase, according to me, is setting the goal for the car. Setting the goal for the entire season, not just for the car, but for the team as well. So once we have all of our research in our hands, we start deciding on a goal, and this goal usually is a quantifiable goal where we can measure our performance, because performance can be an arbitrary thing. We all aim for a higher performance, but if we have to be precise, we try to hit numbers, and we try to actually perform in terms of events, in terms of points. We always want to maximize points in the event, so that's what we're looking for in the concept phase. Once we have a goal decided, all our technical departments sit down together, and we actually have brainstorming sessions together. And what this brainstorming session does is it opens us to new ideas, and it kind of creates a cohesive atmosphere within the team. So that's about the concept phase. Once we're done with the concept, we have a vision of how the next car should be. We start with the design phase of the car. Now, design mainly for a Formula Student project, according to me, is an iterative process. So each technical department is working on their individual project. As I said. So it could land up to a place where you may reach a stage in your design phase where different departments are doing different things, and there is people don't know, there's no communication between them. So the operations department actually maintains the smooth flow of communication, you can say, in terms of design. And we divide our design uh, phase also into different milestones which we need to achieve in terms of getting each sub department sorted. So once we have a design, the most critical thing according to me in design is getting a design freeze date right. So in your concept phase, as I think I forgot to mention, you also have to make your goals and your timeline. So according to your timeline, you know exactly when your design phase should end and when your design should freeze. So based on that date, the team is always trying to hit that milestone in terms of the timeline itself. For manufacturing, I can say we should not start manufacturing. This is something we've learned over the past few seasons and from our alumni as well, that we only should start manufacturing when we have the entire CAD 3D model completely ready. And it's a full, there's absolutely no iterations going to happen after that. Then we start the manufacturing phase. Manufacturing this season actually was quite difficult for a lot of FS teams, I can say, because of COVID coming in. So this was the most critical factor that actually caused us to lose an entire season in terms of the international event in 2020 Formula Student. So yes, manufacturing is an important part itself. And once you're done with manufacturing and you actually have a priority list that you come up with before manufacturing, I forgot to mention that. So when you're manufacturing any component, you need to know in which order you're going to be manufacturing, what are the critical components on the car. And this actually comes down to your assembly. So you want to assemble the critical aspects of your car, like the seat of your car and the chassis of the car, suspension. Your car should be on wheels. So these critical components need to be there on the car itself. So after that, you, as I said, you start with the assembly phase. And once you're done with the assembly, then comes the most, I would say, fun part in a Formula Student team's journey, that is testing the vehicle done. So once you have your car ready, it's quite tempting to immediately start testing. So what I think we have learned from our past mistakes, you should actually try to get the car TI ready. By TI ready, I mean it should have passed the TI checklist that is actually uploaded on Formula Student website. So once you know your car is technically viable to run in the competition, only then you should start testing your car. And once you're done with the testing, you should also try to focus on driver training and focusing on event-wise testing, in my opinion. So this is exactly how we go about in terms of our entire timeline throughout the year. This is obviously a long process, I can say, till we reach till the event. It takes about a year for us for FS teams to actually achieve the target of going to the competition and performing there. So from my perspective, I can say this is the process DJS Racing has been following since a lot of years. Yeah.
Definitely, I like the point you made about how cohesion is the key to making the right vehicle for these competitions. You need to make sure every single subsystem is integrated, well integrated into the design goals of the team, and we see this always being emphasized on Formula Student teams when they bring their cars to the events. It's all about making sure each subsystem does its part and it knows its own priority in terms of performance for the car. So it's great to hear this insight to your design process. Yeah, I would have to agree with you. Testing is obviously the most fun part, but then you have this big manufacturing challenge in the middle. And of course, I can vouch for that fact that if you don't have your full CAD properly ready, you're going to face a lot of problems in manufacturing. I remember I've also faced similar issues. If you don't have the right jig, if you don't take the right tolerances, it's going to have a compounding, this almost type of concertina effect when you finally get your car ready to race. Anyhow, that's great to hear. So with that, let's go to the skid pad event. That is the event which is often overlooked by many people, in my opinion. But the skid pad has a lot of advantages to tuning your car and getting it set for all the dynamic events. So why don't we have a quick run through of what exactly you get from both simulating your skid pad in the design phase and also running that skid pad while testing your car. Maybe we can get a good vehicle dynamic overview of that event.
Yeah. So, am I audible? Okay. So simulating skid pad, by simulating skid pad, we get to know what our timings are exactly, and especially what settings do we need on the car so that to achieve that particular timing, because FS is about to get the fastest time for your car. And in order to achieve that, you need to iterate certain parameters on the car. So yes, the simulations that we do, those usually involve changing of static toe angles or changing the tire pressures. That result in generating more forces on the tires, which definitely helps in cornering the vehicle faster and hence the lesser timings.
Okay, so when you first start designing your vehicle, how do you set your goals with respect to using skid pad as the optimal benchmark to get your vehicle completely ready for an on-track experience? Could you run us through maybe the iterative process that you follow to perhaps make sure that your car is well equipped on the skid pad?
Okay, so being an electric vehicle, so firstly it is definitely to determine the accumulator sizing or the battery package sizing that would be required to complete the endurance. So once those sizings are determined, and after that the transmission department, they usually determine the optimum gear ratio that is required such that they deliver the maximum power. And based on that, we get to know velocity that the car can achieve maximum. And this maximum velocity helps us in determining the maximum amount of downforce that can be achieved on the car. So with the help of the added downforce and the normal weight of the car, we get to know the vertical loads on each of the tires, and by varying parameters such as pressure or camber angles, we can simulate the amount of lateral force that the car is experiencing. And that lateral force is reacting the centrifugal force, and that results in a stable car. So based on these parameters, we get to know what how our car would perform in skid pad.
And also to add to that, the skid pad event is actually uh, a figure eight. For those who don't know, it's actually a figure eight that the car needs to complete in the fastest possible amount of time. So from a design perspective, you can say you can go for the assumption that it's actually a steady state corner, and based on that, you can design your car to maximize lateral force. Now you have to ensure that you're doing this with the correct weight distribution, whatever weight distribution you had decided and you've actually achieved on your CAD and on your vehicle as well. So the weight distribution, the reason it's important because if you're getting any sort of additional yaw movement that is being generated in any part of the track, so that usually leads to loss of driver confidence, and drivers in the Formula student space are actually students themselves. So they're not professional drivers per se, and for them, they need the car to be as predictable as possible. So that's one thing that we take into consideration while designing a car for skid pad. And in terms of setup, there are a lot of parameters that we change, as Ishan rightly said, in terms of the camber angles of both the front and rear wheels, the static toe, and even the pressure, the tire pressure itself. So these are the I would say the characteristics that we take into consideration for maximizing our performance in the skid pad event.
Okay, and in terms of virtual simulation, what sort of tools do you use? What sort of software is usually used for designing your vehicle with the skid pad reference?
Okay, so there are certain lap time simulation softwares that companies make. Some of them are IPG simulation softwares or optimum lap software. So we do not use them. We make our own MATLAB algorithm and we test it. And based on that, we get to know proper an approximate timing of our car in sketchpad.
That's great to hear that you construct your own simulation uh, tool, and that's actually a really good process to follow because um, more often than not, when teams get into simulation, they tend to just put whatever parameters they have in hand, and if there's some parameters they don't know, they just put some dummy value into the simulation. And it's important to remember that simulations run in the rubbish in, rubbish out philosophy. So if you don't put the right parameters in, don't have the right inputs, you're going to get the wrong outputs. And then it's again going to be a domino effect. You're going to have a car that performs nothing like what you want theoretically. And your theoretical car performance is also going to be completely off the mark. So that's really great to hear that you're making your own simulation software. And that way, you know exactly what's happening. You know all the mathematical equations, you know all the control systems that you are incorporating into your car, at least in terms of the mathematical equations. So that's great to hear. Okay, so it's great to have a good insight to the way in which skid pad simulations can be used to make sure your vehicle is perfect when it comes to other events like autocross and endurance. But let's get a little bit more technical in terms of your powertrain. So it's great to see that you've started shifting into electric vehicles. And I noted down that in 2019 is when you made your first prototype for an electric vehicle, an electric FS car. So firstly, what changes did you have to make to your VD design process to incorporate this electric vehicle setup? And also, how many motors are you using right now in your current electric design?
Okay, so right now we are using a single motor for our 2021 season. And regarding changes in the vehicle dynamics department, so firstly, getting to know different parts or different systems in the EVPT. So the biggest thing is the accumulator, and that requires a quite big size. That is a quite big size, and that requires a bigger chassis in the rear side. So definitely the chassis that we used to have in the combustion vehicle is different than that from the electric vehicle. So majority of the changes are at the back of the car, behind the driver, where the motor is placed, motor controller, battery pack, and cooling system if required. So these are the changes that, and majorly the suspension and chassis departments are affected. The aero department, yeah, they need to do certain modifications in their under tray in order to incorporate a radiator design, and maybe mountings of the front wing need to be changed because of unavailability of the mounting locations. Apart from that, there aren't any other changes.
Okay, so that's interesting to note that you're only running with one electric motor. So I would assume that's obviously going to be somewhere in your C cabin, you know, right behind the firewall. And then do you have so do you use like a differential or a spool to transmit that power to your wheels?
Yeah, we're actually using a limited slip differential, 1.5 type Drexler uh, differential. Yeah.
Okay, that's interesting to hear because electric motors obviously they produce about the maximum, or they produce a high amount of torque to begin with. Unlike a combustion vehicle where you need to obviously build up that torque over a set of gear ratios, over a set of gears. So if you're using a differential, do you have like calculations? Do you use calculations of the default ramp angles that are in the differential? And by any chance, do you play around with the ramp angles or the preload that is present in your differential? Because surely the torque coming out of the electric motor is going to be different. That curve is going to be completely different from what's going to come out of your combustion from your IC, right? So how do you work around that in that sort of feature in your vehicle dynamics?
Right. So the differential that we're using, it's working on the ramp angle 40-50 as of now, which is the default ramp angle that comes with Drexler differential. So as we know, as you rightly said, so for an electric motor, the torque from the get-go is going to be much greater as compared to an IC engine, which would give you at peak power between a range of RPMs. So for that, what we are planning to do for our testing phase is where we are going to go for a more aggressive ramp angle, where we would basically go for a setting which is available, that is 30-60. So what that basically does is and even from our previous year's driver feedback, the driver kind of felt that the car wasn't really stable at corner exit, and the car didn't really maximize its performance during corner entry as well. So we sort of have a feeling that the drivers got much more confident, and we can go for a higher and a more aggressive ramp angle in that approach. Yeah.
Good to hear. So more aggressive ramp angle if you're going for a 30-degree power ramp, right? Is you're going with 30 power, correct?
Yeah.
30 power. Wow. So that
30
means
power, 60
obviously
braking.
your car is going to be fully it's going to lock a lot easier your both the wheels. So that means of course you could potentially get a snap oversteer if you load the tires too much, but up till that point it's like an understeering setup. Definitely some sort of a setup that's more suited for an aggressive driver, someone who has good reflexes and can easily control the throttle. So yeah, that's really cool to hear. It's good to hear the insight and the sort of vehicle dynamic changes that happen to your car when you put an electric motor. Now, what are the performance advantages you're getting by shifting to an electric vehicle? Of course, shifting to electric is inevitably happening to almost all locomotives in the foreseeable future. But in terms of raw performance, are you gaining something extra by shifting to an electric vehicle for your Formula Student contenders?
In terms of the motor itself, as I would compare it to a previous experience with the combustion car, so the energy efficiency or the thermal efficiency of a motor is always it's quite great compared to an IC engine. It's almost thrice, if I may say. But the problem with an electric system or a tractor system is that, again, the battery pack that we have in terms of energy density, it becomes a problem for us. So it's sort of like a compromise. So I wouldn't really say something the combustion vehicle actually outweighs the electric vehicle or vice versa in terms of performance. It really depends on your own setup and your own car. Being a first-year electric vehicle, or what we're trying to achieve right now, is we're sort of over-designing a car for the uh, reliability concerns that may come down in terms of testing in our testing phase of all electronic components, which we are not used to operating with. So in terms of that, yes, our car is going to be a bit more heavier compared to a combustion vehicle, and we have adjusted for our our springs, the springs which we are using, and our damping ratios. We've changed stuff like that to incorporate this change. But yeah, according to me, it's sort of like a compromise, and it's going to take us some years to actually achieve that sort of performance that we can actually from this system. But right now, what we're aiming mainly in terms of a goal, I would say, is reliability and clearing the technical inspection at the competition.
Yeah, for sure. Thermal efficiency is always one of the focusing on thermal efficiency is definitely one of the key goals of any powertrain system. Even if you look at combustion vehicles, you've got to optimize your radiator. You need to make it big enough to cool your engine, but not so big as to ruin your packaging constraints in the B cabin. Speaking of thermal efficiency, and in terms of heating, it reminded me of what actually happened in Formula Student India 2016. I remember we were there when we were at the skid pad event. We were about to start, and temperatures were plummeting. I think they were really low. It was freezing in Delhi, I think, that time of the year in January. And it was so cold that some of the engines of many teams were not even firing up simply because of how cold it was. So a lot of teams were like going to the testing area, revving up the engine, just heating it up to get it to an optimal performance temperature, and then taking it to skid pad, only for it to again stall when they start their run. So I would assume by running an electric motor, you probably wouldn't have those issues, right? In fact, I think in colder temperatures, your electronic circuits tend to work a little better.
Yeah, so actually talking about the thermal efficiency of the motor and its performance, like the cooler the motor, the greater efficiency it gives. So that is definitely an advantage. But like you said, the experience you had in FSI with Formula Bharat, it's completely different. Being in Bangalore, it's a lot hotter, and engines tend to heat up and they reach the kill temperature. So, but yes, with a motor, definitely uh, the the issues are much less. But so talking about the radiator that comes, that we were talking about it. So uh, what happens with an EV vehicle is, like in your CV vehicle, you usually have the side pod where the radiator, and it's a pretty conventional thing to find the radiator inside the side pod. What happens with an EV is that EV cars usually eliminate the side pod. So then you have to think, you have to come up with a new place to place it, because the side pods are relatively much smaller as compared the radiators are relatively much smaller as compared to CV cars. So it would not be, it might be a waste to keep a side pod especially for that. So yeah, that is one of the challenges that come with the thermal heating, that you have to think of a better place to place your radiator, and to maintain and to keep your motor in that range, so that you're able to get the maximum efficiency.
Right. So it's very similar to dealing with your brake cooling in a way, especially if I guess one of the advantages you have is you have your motor not really in the wheel assembly itself, not as part of the hub. So because of that, you have a little bit more freedom to play around with that. But surely when you go to more complex systems, when you start integrating motors into the wheels, you're going to have to really start focusing on the aerodynamics and cooling basically everything around that wheel assembly, in addition to your brakes, which are going to be right next to the motor, and it's also going to be some sort of a convective heat transfer. Um, but yeah, I guess there was a lot of details to get into, and we'd really like to know what's happening. As you grow in that field in the electric, in terms of the complexity of electric vehicles. But on that note, let's go to your team's journey through these international events. You said you managed to bag the cost event in one of your international ventures. Can you talk us through what it takes for a team to start as recent as 2013 and make it to the podium in an international event?
Yeah, sorry. So talking about the static events, not a lot of team give enough importance to static events, right? From the beginning, we've always had like a focus on the static events because, uh, so so talking about the international events, if you want to gain, if you want to gain a good rank, then it is really crucial that you do well in the static events because, in terms of the dynamics, it is very difficult to get a car that is performing as well as the fastest cars out there, due to whatever budget constraints or whatever reasons. So it is really important that you give enough importance to static events. Now, what happens with the design event is that usually teams are usually prepared with it because they've actually designed the car. But for the cost and manufacturing event and the business plan, you need a lot of extra time to it. So, and that needs to begin from the beginning, not just like a month before the competition. We have been working on a cost documents, and we've been planning everything throughout the year, and that is what helped us to gain, to get to back that trophy. There are the cost and manufacturing event has a lot of things that are not usually uh, explored by a lot of teams. Like yeah, I think even we have not explored it completely. There are a lot of topics that even we have not touched yet. So there's a lot you can do, and you just need to be motivated enough and interested. I think what really helped our team to gain that podium finish was that they were really passionate about the cost event itself, about what they were learning out there. So that I think plays a major factor, along with obviously planning way in advance and preparing, having mocks, making sure your documents are in place, etc.
Yeah, I'm pretty sure your team would have extinguished like 50% of your budget just for getting enough coffee for your cost team to get going, right? I know the cost event is perhaps the most challenging one. It's just pure documentation. If you have a knack for that, it's just about finding the fine details. But I mean, for you to manage to do that with the cost event of all those events in an international domain is really top notch. I mean, congratulations for that. That in my opinion is probably the most complicated event, the most structured but the most complicated event to get the right amount of points in. Speaking of that international experience, can you run us through some of the key takeaways you've got from all of the international experiences you've had? Also, which international events has your team taken part in up till now? Yeah, Karan, I think you're on mute.
Yeah, so sorry. So we've been to Formula Student Germany in 2014, 2017, 2019. And in 2018, our CV team was in Formula Student Austria, and our EV team was participating in Formula Student East. So I think the participating in the international competition uh, gives a really different experience than what we have in a national competition, because the major criteria would be the teams that are participating there. you really get to experience what the Formula Student culture is all about. Another really interesting thing out there is the innovation and creativity that these foreign teams implement. Like you go to every pit you go to, you're going to see something really different on your car, and you're like, you'll be like, what is this? So that, along with I think even the top notch FS teams are really helpful to the teams that are still coming up. And I believe that is what the Formula Student community is all about. It is about helping and growing together. If you there are some German teams that actually publish their design reports on their websites, which are actually supposed to be uh, classified. Then a lot of DV teams have been making their algorithms public. So interacting with these big teams that have been able to achieve so much really gives us the opportunity to learn a lot. And uh, and yeah, getting having been doing well in the cost event, for us it is uh, we always try to at least do well in the cost event and try to get a podium finish. And yeah, competing in the dynamics there is a completely different experience, because I participated in Formula One Germany 2019, and I was doing the acceleration event on the straight in Hockenheimring. So that itself is a very crazy experience, I'd say.
Definitely a special experience for any driver to be able to drive the car that they worked on, their all of their hard work going into that car, and then they get to control that on circuits where some of the greatest drivers of all time have raced. Definitely does seal the deal in terms of the emotion that you have, just to be there with your team and celebrate, just to be a part of that culture. So of course I see 3 different international events in Germany up till now. Three different events in terms of locations up till now. So I know that last week or a few weeks back, the entire FS community had multiple registration quizzes for international events that went on. Did your team attempt any of those? Do you have any plans for international events this year or maybe next year?
So we actually attempted the all the quizzes. Like the quiz start at 1 o'clock IST and go on up to 11:30 IST. There are a series of 5 to 6 quizzes. So yeah, we did attempt all of those. We were registered for Formula Student Netherlands, Austria East. We were just a little bit lower in the Czech waiting list, and Formula Student Germany had to redo their quiz. So yeah, we would be going for an international competition this year. We are yet to finalize and get done with the registration process.
That's cool. That's awesome to hear. It's good to see all these events opening up again. I think last year was the quietest year in Formula Student history, we could say, or for any motorsport for that matter, in terms of limited competitions, everything being virtual. So yeah, I'm looking forward to seeing how your team goes about tackling this year and all the challenges you're going to face in getting your vehicle out there and winning. We hope to see you guys winning dynamic events as well, making a benchmark, giving a benchmark for electric vehicles out there as well. So on that note, let's start. Let's get to the concluding phases of today's webinar. Can each of you maybe give a good or give a small anecdote of some experience that you've had in the team that's really sealed the deal, and one of the key experiences that you take away from your Formula Student journey?
Uh, yeah, so I'll speak about my own experience at Formula Bharat 2020. So we had a car transported back from Mumbai to Coimbatore, and when the car arrived, there was basically some damage that took place to the suspension assembly and to the drive shafts as well. And we had to go to the competition right after, like, we came one day prior to the competition registration day. So we didn't have much time on our hands, and there were very few people who had actually gone a day prior to inspect the car for any thing that may happen to it. And I remember this quite well in my own experience, that there came a time in the process of actually working on the car and trying to fix the problem, that a lot of us came with the thought that this doesn't make sense. So there may come a time in your Formula student journey where you may question your own self and what you're doing, the amount of time you're doing, because the amount of time you put on something, you actually don't really see that outcome soon enough. It takes a year. It's a long process. So I would advise any fellow Formula student team member who would be watching this webinar that if you ever reach that stage, you should never give up, and always think about that feeling you would get when you see your car run on the track by clearing the technical inspection and just completing the endurance event in itself. So it's not about rankings. There's one more thing I would like to add to this. It's not about rankings. There are a lot of teams which are still trying to reach the top tier teams which are considered in India. According to me, that does not exist. As Karan said before, Formula Student is a space where we learn together. So, and it's usually the smaller teams which learn the most. That at least that's what I've noticed in my opinion. So don't get disheartened when you don't get an award or something like that, because I know the point of going to a competition is actually to win, but Formula Student is a different space. It's to learn, and what you come out of this entire journey when you graduate from your course and your Formula Student experience, you will obviously take back the knowledge and experiences that you have as a Formula Student team member. So yeah.
Yeah, what I'd like to share is my experience at Formula Sprint Germany in 2019. So it was not just my first international competition, but it was my first Formula Sprint competition, and I was the tallest driver. Hence, I got the opportunity to go for the technical inspection. And after the first technical inspection slot was over, the inspectors had given us a list, like a really long list of things that we need to change on the car. Okay, that Ishan out here is smiling because he was also present there. So the list was like really huge, and the inspectors did not believe that the car would ever make it on the track. Right, we had, I think, over 30 issues that we had to deal with, and none of the inspectors thought that we would ever complete it in time to even do any of the dynamic events. And the next day itself, we were on the track doing acceleration. So we actually got a special award by Formula Student Germany for that. So I think that was the most that is the best moment I've had as part of my journey, where the team together achieved achieved something that others thought was not possible. And that is what a Formula Student is about, where you should not uh, to keep trying to innovate. And there are a lot of goals also that when you set, you might feel that these are too ambitious, but you got to start somewhere. So a team working well and together can achieve a lot.
I think that the FSG 90 Never Give Up Award was special for everyone from our team who attended Formula Student Germany. And for me personally, the Formula Bharat 2020, that competition wherein we ranked second in skid pad, even though we didn't had our best setups, but still getting the second award, that was the best feeling that I could ever experience in my entire journey in this team.
Yeah, great to hear. Yep, I think that sums it up. You guys, the three of you together have really summed up uh, the very essence of Formula Student. Being able to face adversity, face all of the challenges, and most importantly, learn at the end of the day. And if you play your cards right and you really do believe in what you've created, you get points, you get the podium. I think, yeah, there's no better feeling than to go up on that podium and receive a prize on stage. Of course, it's not all about winning. Formula Student is all about learning. It's an engineering design competition, but it never hurts to, of course, get those little prizes and feel really good. It's a physical reminder of the hard work that you've done. But I think the most important physical reminder of the hard work you've done is your vehicle itself. And hopefully this year we'll get to see the real vehicles actually running on track, physically manufactured, instead of just running virtually. Oh, yeah, it's great to see your achievements that you mentioned here. That's really good to see. for our audience, feel free to go back and watch these webinars, these series that we constantly put out every other week is solely intended and tailored for inspiring all of you to get involved. There are a lot of competitions, just like Formula Student, out there that you can take part in. Just choose a domain you like, choose a domain you feel you really are passionate about. If you're not passionate about race cars, there are so many other events as well. You have copter events, copter research. There's something called there have been autonomous underwater vehicle events. I mean, the spectrum is huge. So if you're an engineer or you're interested in taking part in engineering competition, just go ahead. Most universities and colleges have these opportunities, and if not, always try to get involved as a volunteer somewhere. Trust me, you're going to learn a lot from that. So with that, I think we're concluding today's episode, today's session, the Explorica series. For our viewers, stay tuned. We're having a lot more sessions coming up in the future, and we start getting a little bit more technical. Getting a little bit more technical now. It's been a good introduction to a lot of teams and the way in which student teams work. Now we'll start focusing more on specific pieces of technology as well, and we'll slowly transition into more core engineering topics. So until then, thank you so much for your time, Karan, Ishan, and Abhishek. You guys gave a really good insight to what it really takes to get there on the top. And we couldn't have been happier to host you. This has been an absolute pleasure for us to have you on board today.
Yeah, it has been a pleasure as well. Thank you for providing us the platform to inspire more engineering students to start FS teams. It's really a great experience.